is a major water body in the state of California. It has beneficial uses including municipal and industrial supply, recreation and aquatic habitat, as well as agricultural supply. Yet, over a 100-mile reach of the river is now impaired due to agricultural return flows. These return flows are carrying over 1 million tons of sediment each year from cropland and orchards in the western Stanislaus County. The return flows are not only carrying sediment, but they are also carrying residual pesticides and fertilizers that have been used on the land. Recent studies have linked DDT to elevated levels in fish tissue in the San Joaquin River, even though DDT has not been used in California for almost 20 years. The growers along the west side are well aware of the problems of this non-point source pollution. They've already begun implementing new irrigation and drainage practices in an attempt to control erosion from their land and increase their productivity, as well as to reduce the impacts on the San Joaquin River itself. Yet the growers must not only continue these efforts, they must enhance these efforts.
In 1991, the West Stanislaus Hydrologic Unit Area Project was formed to qualify growers for aid in meeting the water quality challenge. Formed as a cooperative effort between the University of California Cooperative Extension, the Soil Conservation Service, the Agricultural Stabilization and Conservation Service, and growers, it was one of 75 projects approved for USDA funding in the nation. If your operation is on the west side, you qualify for funding and technical assistance provided through the HUA. During the summer months, the water flow from the area into the San Joaquin River is entirely agricultural drainage water. It carries sediment off the fields and into the San Joaquin River. The goal of the HUA program is to reduce sediment to a level of 300 milligrams per liter, from an average of up to 1,500 milligrams per liter, which exists currently in some waters leaving the fields. Growers can meet that goal by following best management practices, a method or combination of methods involving structural, vegetative, and agronomic or managerial changes.
This video seeks to share some of the best management practices currently being used by your neighbors, and still other practices you might find even more suitable for your operation. In 1992, you have the opportunity to determine the trend of the future irrigations and drainage practices. You also have the assistance of the HUA.
The Soil Conservation Service office is located on North El Circulo in Patterson. You'll probably notice some new faces. We have a new engineer, and will assist you in deciding practices that fit your situation and provide you a letter that you can bring to ASCS and get the process rolling. The recently completed West Stanislaus Sediment Reduction Plan identified that sediment basins are the most critical practice for open ground on the west side.
In case of sediment basins, we've raised the cost share to 75% of the cost of the project, up to $3,500.
The first step in eliminating irrigation-induced erosion and sediment load on the San Joaquin River is identifying contributing factors. Most can be readily recognized by the grower. There are 4 areas to look at: physical factors, system factors, water management, and agronomic management. Physical factors are those that are unique to the West Stanislaus area and are factors that the grower must work with or around to obtain good irrigation. Most of the soils in the HUA study area are clay and clay loams and have a high tendency to loosen and to be carried away in tailwater. Existing or potential problems can be minimized by monitoring the volume and intensity of the water flow. Another physical factor to work with is the slope of the irrigation. Because most furrow slopes range between a 0.2-foot drop per 100 feet run to a 1-foot drop per 100 feet run, the rate of erosion is dependent on soil texture, average slope, and the furrow stream size. The practice of land leveling can correct the slope of your field to improve water distribution and crop uniformity, as well as reduce the amount of irrigation water needed. While physical factors must be evaluated, system factors are directly within the control of the grower. They include furrow length, the depth and slope of your tailwater ditch, and maintenance of your sediment basins. Many of the growers in the HUA study area have already cut the length of their furrow runs to less than 1,000 feet by adding gated pipe or siphon tube ditches across the width of their fields. Benefits of shortening the length of the furrow irrigation include better water distribution for your crop and potential water savings. And by implementing this practice, you can also reduce the size and cost of additional best management practices, such as those associated with sediment basins. According to studies, the majority of sediment leaving farms in the study area is lost from the lower portion of the field, where the outfall of a tailwater ditch is lower than the furrows. This leads to a self-perpetuating erosion process as the furrow end continuously erodes and further increases the slope. A drainage ditch maintained at a reduced slope can reduce furrow runoff velocity and allow sediments to settle before drainage water exits the field. Just as important as monitoring what happens to water after it's applied to your field is monitoring water as it's being applied to your field. Erosion can be minimized if the properly measured stream size is applied for the proper time of set and simply replaces the soil moisture deficit. The Soil Conservation Service in the West Stanislaus Resource Conservation District is working to obtain a mobile irrigation lab service to provide irrigation systems evaluations to growers at no direct cost. The mobile lab service technician identifies operating problem area solutions. With this information, the grower can identify which problems, when corrected, give the greatest return. One tool designed to acquaint growers with the concepts such as irrigation scheduling and timing, uniformity, irrigation efficiency, crop stress, and drainage problems is the computer program AgWater. AgWater can help you perform a self-evaluation of your irrigation systems and management practices, and as well as tabulate the results and tips to solve problems. AgWater is available for your use at your local irrigation district office and at the Soil Conservation Service office. You also have available to you a California Irrigation Water Management Information System, or CEMA station, located off Highway 132, about 10 miles from Modesto. On an hourly basis, the automated station and 64 others within the CEMAS network provide weather data, including rainfall, solar radiation, air temperature, wind speed, and humidity. This data, along with the specific crop and soil information for your fields, can be used to schedule effective irrigations. Other resources available to aid in efficient irrigations include managerial BMPs, such as basic types of sensors and techniques to measure soil moisture and plant stress. The feel method is probably the oldest and simplest method of estimating moisture, based on the feel and appearance of the soil. By using information available on a standard description chart and by soil texture, you can estimate the soil water content for a soil sample collected in the rooting zone of the plant. Tensiometers and moisture sensors are simple, reliable, and inexpensive tools for monitoring soil moisture. Tensiometers measure the water tension in the soil to help determine when to irrigate. Moisture sensors evaluate soil moisture indirectly by measuring the electrical resistance between two electrodes attached to a small cast block of gypsum buried in the soil. Visible symptoms of the plant stress can also reveal if there are irrigation problems. However, by the time some plants show symptoms, many have suffered stress that will hurt productivity. Cutback irrigation is also an effective water management practice in which the furrow stream flow is reduced or cut back when water reaches the end of the field. For example, if there are 2 siphons per furrow, one siphon would be pulled after the water reached the end of the field. In addition to reducing erosion and sediment leaving the field, cutbacks decrease water usage and increase irrigation efficiency. A particular advantage is that there is no installation cost, and it can reduce the size of maintenance cost for other necessary practices, such as sediment basin and tailwater ditches. Sprinkler germination, or pre-irrigation, uses less water than needed in furrows, obtains better seed germination, and cuts water cost. Vegetative or agronomic best management practices are subtle changes in the way you use your land that naturally reduces the non-point source pollution, as well as provide other benefits. Orchard cover crops, filter strips, and conservation tillage are all very beneficial practices. They naturally protect the soil surface, conserve moisture, and decrease water flow and filter sediment. All are easy to install and maintain, can help you reduce costs associated with water runoff, tillage, and herbicide applications. Permanent cover crops are reseeding winter annuals planted between tree rows which last about 10 to 20 years when maintained by mowing and disking. There are also temporary cover crops, which are short-lived annual grasses, usually planted in the fall after furrow-irrigated orchards have been harvested. Once planted, they remain throughout the winter and reduce storm runoff-induced erosion. In the spring, you can incorporate cover crops into the soil and, if furrow irrigation is used, reshape your furrows for the next irrigation season. Conservation tillage is any tillage system which leaves at least 30% protective crop residue on the soil surface after the planting. You can alternate crops that produce low amounts of residues with high residue crops to average out the protection. Eliminating even one tillage can reduce erosion by 23 to 30%. Filter strips are densely planted crops, such as cereal grains, grasses, and alfalfa, grown along the tailwater ditch and harvested to offset the installation cost. When properly installed and managed, they can remove 40 to 60% of the sediment from the furrow runoff. Structural changes should be considered to address your irrigation and drainage practices. Sediment basins installed at the end of a tailwater ditch prevent sediment from reaching the river. A well-planned basin can retain about 65 to 95% of tailwater sediment, so it can be very beneficial. To be effective, water should be allowed to settle for at least 2 hours, and water in the basin should have minimal velocity. It is important to maintain the capacity of a sediment basin by having it cleaned regularly. As sediment accumulates within the basin, the water retention time decreases, lowering the sediment removal efficiency. An annual cleaning will ensure the highest sediment removal efficiency. Tailwater tarps are portable check dams placed at the intervals in the tailwater ditch. These tarps serve 3 major functions. They act as mini basins by removing the heavier soil particles from the runoff water as it passes between intervals in the tailwater ditch. They also control water velocity by eliminating erosion in the tailwater ditch. Mini basins can also reduce the slope between the furrow end and the drainage ditch, which reduces erosion. Effectiveness ranges from 40 to 75%, depending if the basins are regularly cleaned. Best management practices can also be in the form of how the water is delivered into the field. Micro-irrigation, such as micro-sprinklers and drip irrigation, are one of the most effective ways to irrigate directly to the root zone. A system consists of a network of pipes and emitters that apply filtered water to the surface or subsurface of the soil in the form of a spray or small stream. Emitters discharge only a few gallons per day, thereby reducing water applications, erosion, labor needs, and insect and fungus problems. There is no runoff, and there is the advantage of applying fertilizers and fumigants directly through the system. Aluminum-gated pipes have closely spaced gates for distribution of water into furrows. They can be used to split irrigation runs. They are easily placed and movable. Solid set sprinklers offer the means to efficiently and uniformly apply water and maintain adequate soil moisture for ultimate crop yields. Sprinkler systems can eliminate runoff and stop sediment loss from the field. Surge irrigation utilizes gated pipe and a special valve that moves water back and forth between 2 sets of furrows. The rotation causes the water to flow down the furrow in a series of pulses. The wet then dry pattern of the water flow allows effective distribution, using up to half of the amount of water needed by the continuous flow. There is a minimal runoff, and this method reduces deep leaching. It is an automated system which provides labor savings as well as potentially raise your crop yields. Tailwater return systems are designed to collect irrigation runoff water that would normally discharge into a drain. Water that flows off the low end of the field is collected in a sump and then reused for irrigation purposes on the same or adjacent fields. These systems can reduce sediment leaving the field by 99%, and practically all tailwater is recycled, offering significant water savings. In addition, it is less expensive than pumping from a well.
California has recently adopted a new water policy. The policy is known as the Inland Surface Water Plan, and this plan now sets numerical as well as toxicity objectives on all surface waters in California. If West Side growers want to keep the state from intervening in their practices and prevent the possibility from having their discharges regulated under a permit process, they must continue to demonstrate that they can control their own water quality using their own best management practices. Now's the time for growers to become proactive and to take a hand in their own future. If they're not willing to control their own discharges, the state will come in with a regulatory program to protect the beneficial uses of the San Joaquin River.
Recognizing and reacting to the water quality problem in West Stanislaus County is not something new for area growers, but the implementation of the HUA means additional support. As you've seen in this video, even small changes in irrigation and drainage practices can bring about beneficial returns if they are evaluated by the needs of the grower and properly maintained. We realize that a lot of material has been covered in the short span of this video. The SCS Water Resources Planning staff has developed a specialized guide, the West Stanislaus Sediment Reduction Plan, which expands on the information which has just been discussed. This plan can be obtained from your local SCS office. Remember, with HUA you have the opportunity to select from proven best management practices and avoid the possibility that access to the San Joaquin River may be curtailed and state-regulated practices mandated. It means changing some of the old-time practices that were pioneered in this area. But with the HUA, you can meet that challenge to the benefit of your operation, the public at large, and the generations of Westside farmers to come.